Now that we have some interesting objects to work with, we need to increase our ability to control the order statements in the program are performed by the computer. When statements are done by the computer, we say they were executed, even though it sounds kind of grisly. We've used three types of control structure so far: if statements, while loops, and methods. What all of these control statements have in common is that they change the order in which the statements are executed. If statements change the order of execution by deciding whether a statement will be executed or not. While loops change the order of execution by deciding how many times a statement will be executed. And methods change the order of execution by causing the program to do their instructions before continuing on with code. We're allowed to put one type of statement within another. For example, we can put an if statement inside a while loop or a method inside a while loop. This is called nesting control statements. Consider the code below that calculates the number of days in a month that you get more than 100 text messages. We'll end the data using the sentinel value, -1. We can't just count the number of days in a month, since different months have different numbers of days. -1 is a good choice for a sentinel because you can't get -1 texts. Int, lots of text days equals 0. Final int, lots of text equals 100. Scanner input equals new scanner, system in. System out print line, enter the number of texts each day this month, followed by a -1. Int text equals input, next int. While text not equal to -1. If text greater than lots of text text days equals lots of text days plus 1. Text equals input dot next int. System out print line, you got more than lots of text plus text in a single day plus lots of text days plus times. There are a few things to notice about this code. This code uses a technique that's called a priming read. I read the first value for text before the loop started. That may look wrong, but it's a logical order when you're dealing with a sentinel, since it would be possible that someone would enter the sentinel value first. In that case, the loop wouldn't be entered at all, and the correct results would be shown. The value for the second iteration of the loop is read at the end of the first iteration. The reason you do this with a sentinel is that you want to exit the loop immediately when the sentinel has been entered. If you're wondering why we call this a priming read, it's similar to priming a pump. If you've ever had to pump water from a well manually, you probably know that you sometimes have to pour water down a pump to pump water up. The read before the loop is like pouring the water down the pump. I admit the analogy isn't perfect. Nesting is a profound idea of computer science. You've seen nesting before if you store files and folders on your computer. Folders contain files and other folders, and those folders contain files and other folders, and so on. The fact that a folder can contain a folder, and that that folder can contain yet more folders, is a particularly elegant example of nesting. This shows up really nicely on a Macintosh computer, where each layer of folders is in a vertical list and moves left to right as the folders are open and closed. Another way we can improve our use of control structures is to learn to combine Boolean variables together. There are three essential operators for Boolean variables: and, or, and not. The symbol for and in Java is a pair of ampersands. The symbol for or in Java is two vertical lines. The vertical line key is usually on the right-hand side of the keyboard above the Enter key. Not is an exclamation point. While we use these words in English all the time, their computer science meaning is much more precise, particularly with or. If I say, I'm going to the store or picking up burgers, you'd probably be surprised if I did both. But in Java, or is true when either one or both of the Boolean operands are true. The and operator works pretty much the same in English and Java, as does the not operator. Suppose we want to count the number of words in an array list of strings that start with a capital letter. You might think we could do something like this: if A is less than or equal to letter which is less than or equal to Z. But that doesn't work in Java. The problem is that A less than or equal to letter is a Boolean, and true less than or equal to Z doesn't make any sense. So we have to use logic operators to combine the test of whether the letter is bigger than the character capital A and the letter is smaller than the character capital Z. Let's look at some code. Int count equals 0, Int starts with cap equals 0. Array list of string, list. Let's assume this list is constructed and data was entered elsewhere. While count is less than list.size. Char letter equals list.get of count, char add of 0. If A is less than or equal to letter, and letter is less than or equal to Z, starts with cap equals starts with cap plus 1, count equals count plus 1. This code steps through the array list of strings named list one element at a time. It takes the first letter off the string and stores it in letter. Notice that I have two dot operators together on one line. The left dot operator applies to the list, and the right one applies to the string that's returned by the list.get method. If you find that syntax confusing, you can pull the string out of the list in one step and store it in a variable. Once we have the letter, we can test to see if it's between capital A and capital Z and increment the counter if it is. Now that you know how to nest control statements and use logical operators, we'll be able to create bigger and better programs.